How much do you truly know about the enigmatic black holes, the captivating celestial bodies that are as terrifying as they are fascinating? These cosmic phenomena have been a staple of science fiction, often depicted as swirling portals to other dimensions or galaxies. But what does science say about these intriguing objects? Black holes are regions in space where gravity is so incredibly powerful that nothing, not even light, can escape its grasp. They're like the ultimate cosmic vacuum cleaners, sucking in everything that strays too close. This is why they're black. Light can't get out, so we can't see them. They're essentially invisible, with their presence known only by the effect they have on the things around them. Their mysterious nature has given rise to many misconceptions. Some believe they're portals to other universes, or that they can devour entire galaxies. But the truth is a little more grounded, albeit no less fascinating. But where do these cosmic monsters come from, and what happens to matter that gets sucked into one? It's a cosmic tale of death and rebirth. The birth of a black hole is a spectacular event, a consequence of the death of a massive star. This story begins with a star, not just any star, but a massive one, much larger than our sun. This star lives a fast and furious life, burning through its nuclear fuel at an incredible rate. However, like all things, it can't last forever. When the star exhausts its nuclear fuel, it can no longer sustain the heat and pressure at its core. This lack of pressure allows gravity to take over, causing the star to collapse under its own weight. This collapse triggers a massive explosion, a supernova, which is one of the most powerful events in the universe. It's so bright that it can briefly outshine entire galaxies. While the outer layers of the star are blasted away in this explosion, the core of the star continues its collapse. And here's where things get really interesting. The core implodes, crushed to a point of infinite density known as a singularity. This singularity is so dense, so heavy, that it warps the fabric of space and time around it, creating a region from which nothing, not even light, can escape. This is the event horizon, the point of no return, and it marks the birth of a black hole. But the birth of a black hole isn't just the end of a star, it's also the beginning of something new. Black holes are not just cosmic vacuum cleaners sucking up everything in their path. They're also engines of creation. The material they draw in can be shot out in powerful jets, helping to shape their surroundings and possibly triggering the birth of new stars. So we've witnessed the spectacular birth of a black hole, but what happens inside this mysterious entity? Scene script. If you were to journey into a black hole, what would you find? A gateway to another universe or a one-way ticket to oblivion? As you cross the event horizon, the point of no return, you'd be subjected to a process known as spaghettification. Yes, you heard that right. Spaghettification. It's as bizarre as it sounds. This term, coined by the legendary physicist Stephen Hawking, describes how the intense gravitational pull of a black hole stretches anything that comes too close into long, thin shapes, much like strands of spaghetti. Your journey would not be a pleasant one, as you'd be stretched vertically while being compressed horizontally. The disparity in gravitational forces would be so great it would tear you apart, atom by atom, before you even reach the heart of the black hole. At the heart of this darkness lies a point called the singularity. This is where all the matter sucked in by the black hole is believed to be crushed into an infinitely small, infinitely dense point. It's a place where the laws of physics as we understand them simply break down, a place of infinite curvature and infinite density where time and space become indistinguishable. But why can't light, the fastest thing in the universe, escape a black hole's gravitational pull? It's because black holes warp the fabric of space-time so intensely that all paths, even those of light beams, curve inward. Picture this: you're trying to run up a down escalator that's moving faster than you can run. No matter how fast you go, you're not making any progress. That's what it's like for light trying to escape a black hole. So, are black holes gateways to other universes? Or are they the ultimate cosmic shredders? The truth is, we still don't know for sure. What we do know is that they're one of the most fascinating and mysterious phenomena in the universe, a true heart of darkness. Now that we've journeyed into the heart of a black hole, let's explore how these cosmic entities meet their end. Just as they are born, black holes also die. But unlike their dramatic birth, their death is a slow, quiet process. Imagine a candle, flickering in the vast expanse of space. One might think that a black hole, with its immense gravity and insatiable hunger for matter, would last forever. But the truth is, like all things in our universe, black holes have a finite lifespan. And the cause of their demise? It's something called Hawking radiation. Let's dive into this concept a little deeper. Back in the 70s, physicist Stephen Hawking proposed a theory that black holes aren't completely black, but emit small amounts of thermal radiation due to quantum effects near the event horizon. This radiation is now known as Hawking radiation. Hawking radiation is derived from the principles of quantum mechanics, the branch of physics that deals with the smallest particles in the universe. Quantum mechanics posits that pairs of virtual particles are constantly popping in and out of existence throughout the universe. Usually these particles annihilate each other almost as soon as they form. But near the event horizon of a black hole, one of these particles can fall in before this annihilation happens, while the other escapes. The energy for the creation of these particle pairs comes from the black hole itself. So, each particle escape is like a tiny energy withdrawal from the black hole's account. Over time, these withdrawals add up, and the black hole begins to lose mass. This process is incredibly slow. For a black hole with the mass of our sun, it would take about a Google years, that's a 1 followed by 100 zeros, to completely evaporate. That's far longer than the current age of the universe, which is only around 14 billion years. So, from birth to death, black holes lead incredible lives. But what are the key takeaways from our cosmic journey today? Black holes, these celestial enigmas, have fascinated us for centuries. Today we've delved into their life story, from their spectacular birth to their slow, quiet death. Ponder for a moment on the birth of a black hole. These cosmic phenomena are not born from the stardust of an ordinary star, but rather, they are the offspring of the most massive stars in the universe. When such a colossal star exhausts its nuclear fuel, it collapses under its own gravity, giving birth to a black hole. But what happens inside a black hole? The simple answer is we don't know for sure. The laws of physics as we understand them break down within the event horizon, the boundary of a black hole beyond which nothing can escape. Some theories suggest a singularity at the center, a point of infinite density where space and time are distorted beyond comprehension. Others propose a portal to another universe or a different part of our own. The truth remains shrouded in the heart of these cosmic beasts. As we've discussed, nothing can escape a black hole, not even particles or electromagnetic radiation such as light. This is due to the incredibly strong gravitational pull of the black hole, which bends the path of light so much that it's drawn back into the black hole. Thus, black holes are invisible to the naked eye, their presence only detectable by the effect they have on surrounding matter, and finally the death of a black hole. Black holes are not eternal, they evaporate over time, a process known as Hawking radiation, named after the renowned physicist Stephen Hawking who first proposed the theory. This slow leakage of energy eventually causes the black hole to shrink and ultimately disappear completely, a quiet end to an entity born out of a stellar explosion. In this brief journey, we've just skimmed the surface of the complex and mysterious world of black holes. There's so much more to learn, so many more questions to ask. As we continue to explore the cosmos, who knows what other secrets these celestial monsters hold? Until then, keep looking up, keep questioning, and keep exploring the universe around us.